Good evening, everyone, and thank you very much for taking the time to listen to me. So AI has come into prominence, but it's certainly not a new subject. The fact that it has now become a hot topic, shall we say, that people have started to get concerned about what we have to do to govern it. Now, I'm also going to point out that, in fact, a lot of the things that AI gives us help us to actually deal with security and perform our operations as compliance, governance, and risk officers. So, right, there we are. I now know what I have to do. So I'm going to start off by talking about what is AI. And then I'll talk about AI and its use for governance, and go through a scenario which takes into or illustrates some of the challenges that we are faced with. And then finally, finish off by some of the research that we have been doing into the regulation and the atmosphere of AI around the world. So the problem is that AI has become an umbrella term, and it actually includes many, many different technologies, each of which are at different levels of maturity. But to step back a little bit, the notion of trying to replicate the way that people behave is not new. And if you go back to the 19th century, you can see the amazing mechanical devices that effectively clockmakers made, which would mimic the behavior of animals and people. In a sense, Alan Turing talked about this idea in his early research papers. But probably the critical point from today's point of view is in the 1940s, when some mathematicians came up with this idea called threshold logic, and we will come back to that later on. Now, at the moment, what we have is we have machine learning, which is the mainstream stuff that is being pushed by what we are calling the AI, or the machine learning cloud services. So all the major cloud service providers have leapt onto this banner. In a sense, the reason behind this is very clear. And I remember going to a talk by Microsoft where they introduced a lady who was using their stuff, and she was extolling the virtues of the fact that she had 393 cores and some many gigabytes of memory involved in her machine learning. So the cloud service providers are delighted by machine learning because of the resources that it consumes. Now, machine learning is part of the technologies that have been used to bring out the other things like robotics and computer vision and natural language processing, but is not the only thing. And so each of those disciplines has its own, shall we say, specialization. And in fact, what has happened in the way that the market has gone is that if you go to one of these cloud platforms, and I don't think I'm doing any advertising by saying that Google, AWS, Microsoft Azure, and IBM all have machine learning and so-called AI stacks available. And these will include pre-canned natural language processing and computer vision. And in that way, they make it relatively easy to put together your own system to do things. For example, to build chatbots or to do your own visual inspection of components. The same is true of robotics. Now, machine reasoning is something that is moving, shall we say, is still at a very seminal stage. But nevertheless, it is something that is being heavily investigated by the data aggregators. And the simple reason for this is that the problem of being able to teach machine learning needs people. And if only you could sort of accelerate the process of working out how to do new analyses, then that would be a good thing. So what we're going to look at is machine learning. Now, the interesting thing about machine learning is that it actually creates from the software lifecycle a completely new development process. And this is a data-based development process, which involves training data, which you have to categorize. And that training data is used to create a model, which is the learned algorithm. And that learned algorithm is then used on the live data. So it's similar to the time series analysis process that would have been done in the past, but it actually involves creating new learnings. And this is highly based on this notion of threshold logic. And to, again, give you an idea of the time scale in this, that the perceptron, which is the earliest recorded machine learning idea based on this threshold logic, was published in about 1956. So what has happened in the last 50 years is that computers and storage have increased. Indeed, I spent the best part of 10 years in a company that some of you may remember, called ICL, in what we call the Knowledge Engineering Business Center, which was working on the ALVI project. And many of the ideas that we see now were understood at that point, but what didn't exist was the computing power and the storage power that was necessary to make them practical. And that is the key thing that has changed. The ideas have evolved as they have become more practical, but it is computing power and storage capability that has made the big difference. So that's what we're talking about, is really AI. Now, the interesting thing is that AI has an enormous amount of applicability to the problems of governance. And when we look at what governance is concerned about, it's really about this intersection of these three things: that we have risk, we have compliance, and we have ethics. And much of what has been thought about in the compliance area has really been concerned with risk and the intersection of that with the need to comply. And in a sense, we've kind of left the question of ethics to the people that create the compliance rules. But as we move into a new world or a new technology, then ethics becomes more and more important. And as was pointed out by the then president of the BCS a couple of years ago, that if we do not take into under our wing the problems of ethics, then we will find that the acceptance by the general public is colored by that. And you see the problems that have arisen most recently around things like getting people to accept the coronavirus vaccine, and all the kinds of tales that have gone around about how that is being forced on people for all kinds of amazing reasons. And so it is really important, as new technologies emerge, to bring along the rest of humanity with you. Otherwise, you will find that the benefits that you could get from that technology are in fact nullified by non-acceptance. So when we look at the problems of governance, what has happened in the world is that we've had a tidal wave of regulation, which has followed to some extent from concerns about the excesses of the way large corporations, and in particular the data aggregators and the financial institutions, have worked, that the IT and the systems that we know have now creating unbelievably enormous amounts of data, which we're not sure how to analyze. But when things happen and you are interrogated by a barrister, it then appears that you had this data and you weren't paying any attention to it. And part of that comes from the problem that the difficulty of having the skills that are needed. And if we layer on that AI, this is a new technology which has the ability to cause new ethical and compliance problems, but also gives us a set of tools which can be used to help with the problems of compliance. And so to look at some of the examples of how AI is being used, and these are taken from the kinds of things that we as industry analysts get told by the large software vendors and the large service vendors that in fact want to persuade us about how good their stuff is. And this is a pretty common problem, that often you find that there are so many potential outcomes or use cases or circumstances within a regulated area that what should be a simple process becomes one that is very error prone unless you know all of the pitfalls. And so whilst it looks like it's a well-regulated, well-documented area, in fact, a greenhorn and a not very experienced person can easily fall down a hole. And so one of the areas that people have found this useful is to help create systems that help, shall we say, junior staff navigate complex rules. And these reduce the risk of inadvertent non-compliance and also saving cost. And so this is primarily an illustration of rule-based systems where you have a very clear set of if-then-else conditions, but people don't realize the holes that you can fall into or the breadth of the things that you need to take account of. And so these kinds of systems were systems that we were working on in ICL in the 1980s. And indeed, one example of that kind of thing is complex configurators, where there are many ifs and buts about how you can put together a complex product. And that if you make a mistake in the components that you order, then it can all go horribly wrong at the end. And anyone who has had a kitchen fitted will understand what I'm talking about in that I've never had a kitchen fitted where everything arrived when it should have arrived, and there were no problems. And that's effectively a configuration problem. Now, another area that is to do with the vast amount of event data that is now aggregated along all of our security systems and making some kind of a sense of this. And so it turns out that in a way, every organization's event data is slightly different. And what is normal in one organization may not be normal in another organization. And a lot of security analysts spend a lot of time trying to figure out what is normal, and then trying to decide whether or not when things are happening, there really is an abnormality. So what you need is a constantly self-improving system that can learn what is normal by being prompted, and then can identify what is not normal, and can adapt to both new threats as well as changing circumstances. And so in some ways, nearly every one of the security logging tools has some kind of user and entity-based behavior analytics in it. And most of these, to some degree or another, are based around this kind of technology, and they work to a reasonable degree. Now, another approach is the one of the intelligent assistant. Now, this is actually moving further forward, and the range of things for this really range from medicine through to information security. And so if you look at the medical situation is that you can train, and IBM have demonstrated, as well as other companies have demonstrated, how they can train their system to be extremely good at recognizing particular patterns in pathological samples and so forth, and that they are much, much better at doing that than the human eye or the relatively poorly trained assistant. So this kind of approach can act as a way of enhancing the power of the less well-trained analysts, or indeed of doctors. Now, in the question of the intelligent assistant, I've talked here about the IBM Q Radar Security Advisor. And once again, this is an interesting story, because the way it was told to me was that they had to train Watson to read all of the kind of data that is written on websites and in the various sort of manuals about how to configure things and social media, to be able to make kind of some sense of this and to update itself as new information becomes available, and then to categorize events and anomalies against this. And this was a painful, an incredibly painful task. They went with their best security advisors, and in the course of this training almost gave up. But in the end, they found that it was worthwhile, almost for the reasons that I was describing earlier on, which is that that the thing that it helped with was to help people who were less skilled to be better at recognizing the diversity of factors that they had to take into account in order to come to a good conclusion. So the intelligent assistant is something that is now practical. And finally, again, this is another thing from IBM. And of course, IBM has this group that they acquired, which is effectively a group of experts to do with financial regulations. And in the finance industry in particular, there is this tidal wave of regulation. And many organizations have many people trying to just keep up with the existing and new regulations that are appearing, and to relate what these regulations mean against obligations that they have in them, and what obligations they have against controls, and then to be able to see whether or not they have appropriate controls and hence what they need to do. And so this compliance assistant that they have been working on and have created is targeted on that kind of area. And once again, it involves being able to deal with the kind of data that comes from written regulations. So it is taking natural language from a regulation and recognizing what that means in terms of obligations, and then being able to map controls and obligations so that you can look at some kind of controls database to say whether or not you have the controls that you need through one of the various GRC tools, so that you can then say when a new regulation comes along, what you can actually do with that. And this has been further extended by introducing things like natural language processing, so that you can train a system to monitor the activity of traders, for example, by looking at their emails and their phone calls to see whether or not there is any evidence of nefarious or non-compliant activity taking place. So those are some of the examples. So I'm now going to look at a scenario. And once again, this scenario is taken from a real life case study. And it's really a very simple idea, which is that if you have a very large cloud system, shall we say, that is in use worldwide, then you have a large number of authorized users who are using this, but you also have an even larger number of potential adversaries who would dearly like to get in, to steal the data, to use your resources, and generally speaking, break the law. So what in fact you might say is, could we use machine learning to help us with this? And sort of the idea would be that what we do, this is one of the things, and one of the interesting things is that in the IT business, the only thing we tend to really know about is IT, and the only thing we've got lots of data about is, in fact, the things that our IT systems are doing. So what this lives on is the fact that over time, we build up an enormous database of who has authenticated, how they authenticated, and then over time, whether or not there is evidence that following that authentication, the activity was normal or abnormal. So would it be possible to take that data and to analyze it with some kind of inference engine and decide, make a better decision at the time of authentication as to whether or not that, that a particular authentication was a good one or a fraudulent attempt. And so that was the idea. And this was actually done by one of the companies that we deal with. And so the first challenge that you have to do with this is to label the data. Now, this is why I say that the development process has changed, because the development process that you now have to undergo involves people who can look at the data and can identify and classify the data as to in different ways. So you get the people who understand how to read that data are heavily involved in the process of training. And so that involves taking the classification of the events together with the knowledge that you have about threats and being able to classify all of this data in a way which gives you the following sort of kind of outcomes, that these are cases where that was a genuine attempt to log on, or that was a genuine refusal of somebody who was trying to attack it. And what you want to avoid, which is you don't want your good paying customers to be phoning you up to say, hey, your system that I'm paying you a ton of money is not allowing me to get in. Or they're phoning you up and saying, well, in fact, you've got, we've got all kinds of nefarious people coming in and they're crawling over the data we've got in your system. So this challenge is that you have to be able to identify those kinds of data in the first place. And then you have to go through the process of labeling that data. And that is not an insignificant task. And only when you have labeled data can you then actually go through the process of learning, where you sort of teach the system to recognize those things. And here is where it becomes difficult, because when this learning system gets the wrong answer, you have the challenge of why did it get the wrong answer? Now, if it was a human being, you can have a dialogue with it. You can say, well, why did you think that was the case? And like you would have with a student, and then find out where the error was in the reasoning that the student went through. But with a dumb inference engine, which is all based on threshold logic, it's much more difficult. So actually correcting the system can become enormously difficult. So to give you an idea, this was a major cloud service provider. They put a team of 18 people on it, and it took them the best part of 18 months to 2 years to make this work. And once again, in the middle of this, they nearly gave up because of the aggravation that they were having with trying to understand how this was getting things wrong. But having done it, they said, well, they started off with, they had categorized what they believed were about 20 or 25 rules for classification of data, the system immediately doubled that number and came up with better rules and more rules, and was capable of adapting to the changes in the threats. Because what happens is the bad guys recognize when they learn a technique that can thwart the system, and when that technique ceases to be productive, they look for another one. So this is not a static problem. Now, so having said all of those things, we've now actually got to a point where we've got something that that works. What are the challenges? And so we've got a whole host of challenges, which I'm going to look at in more detail what some of them are. And one of the most difficult things is explainability. And to give you an idea of explainability and why explanation matters, you know, if you have autonomous braking in your car and you are about to run down a pedestrian, but it stops you, you do not have time to have a dialogue with your car about why it's put the brakes on. However, if you go to the doctor and the doctor says to you, "I'm sorry, but you've got a very serious illness," then you would rather have a real explanation than, well, the machine says so. So how can you improve explainability? And so first of all, you need to have some kind of training data that is understandable. And then you need to have some way of being able to interpret it. And one of the best forms of that data is if it is in trees or rules. But most of the useful stuff that we're now doing with machine learning is done through inference. And so that is even more difficult because you need to have, you've effectively got a kind of black box model where you need to be able to add some algorithms to it that will help you to explain what is going on. And again, to give you another example of this, that again, and this is an old example, that back in the 80s, we came across a group that was exploring chemical structures that might be useful as drugs for medicine. And this was coming up with answers. And the thing failed completely because when you have a chemical structure that you want to investigate to become a medicine, you're going to have to invest a very large amount of money. And saying to the venture capitalist, this looks a promising chemical structure without being able to give a reason why is not going to get you $1 billion. And so you can then come up with local models like this, local interpretable model agnostic explanation, this so-called LIME approach, which can also be extended to images. And dealing with images is a particularly challenging thing because what, again, to give you a real example of image classification, again, some time ago, there was a large project funded by the US Department of Defense, which was for the analysis of aerial photographs to identify weaponry hidden in the undergrowth, so to speak. And this produced a very good result on the training data, but was a disaster when was exposed to live data. And it turned out that the training had identified that all the pictures that had tanks in them, the weather was sunny, and all the pictures that didn't have tanks, it was cloudy. So the machine learning can often come up with a stupid example. Now, to give you another challenge, this is the challenge of data privacy. Because what I just described we were going to do at the beginning of this was to go and analyze this ton of data. And of course, well, we're no longer in Europe, but we're certainly subject to the 2018 Data Protection Act. That places limitations on whether or not and how we can use data. And so when we look at the training data, which is about IP addresses, user identities, user locations when they are logging on, pretty much everything you can think of is personal data. So if you then say, well, are we actually storing and processing this data under GDPR in short terms? I think the answer is undoubtedly yes. So is this fair and lawful? Well, I think we need to ask a lawyer about that. Now, I've given you that particular example, but everywhere where people are thinking of using that, they're almost invariably going to be thinking about using data that they have collected for some other purpose. I don't think I've seen a thing, which says we're going to use your data for unknown machine learning in the future. So you have a problem that it may be legitimate, it may be in the benefit of the people, but you need to check. Now, another challenge is the one of bias, and there's been a lot of problems that have been brought up to do with image recognition failing to make a good job of recognizing non-white people and making a complete disaster of the way in which it identifies people who are not white or that are not male and white. And so bias is a problem. And this led to IBM coming up with this thing called the Fairness, Accountability, and Transparency model, which was to do with how you can deal with managing the training data. And this is a typically compliance-based approach where you look at your data, you check the data to make sure that it isn't biased, and you all the way through this development process, you are keeping track of what is being done. And well, you can't fault that, except what actually happened was that some mischievous academic saw that this had been put forward, and they wrote this wonderful paper that you can follow here, which used that technique against a proposal which they called the Logan Nolan Industries mulching proposal, which was basically saying that we would have some artificial intelligence that would send drones out to recognize people that are over the hill like me, to capture them and take them to a mulching plant where they would be turned into nutritious slurry and help humanity to make ends meet. So it is very difficult to come up with simple sets of rules which cannot be misused. And in addition to that, you need to recognize, and this is really what that system was trying to do, that says that the whole AI or machine learning development process needs to be recognized for what it is and to be managed for what it is, and that this development process is more of a journey rather than a destination, because whatever you have worked out today will be changing tomorrow. And so you need a continuous improvement process based on the learning, the model, and the new data that you acquire. Now, there are a number of models that have been brought up, and I will talk about these in a moment or two. But in fact, this is a heat map. I think we all know about heat maps. And what this is talking about is taken from the Singapore AI governance framework, which is looking at where you need more or less human involvement. And so this is basically saying what I suppose is pretty self-evident, which is where there is a low probability of harm, and if it did cause harm, that is relatively low, then you don't really need to have a human in the loop. If, however, you are making a decision which has a high probability of causing some significant damage, then you really need to have a human in the loop. And this illustrates simply one of the dimensions of the ethical considerations that you need to take into account. The other challenge, which I want to get hold of one of these, is the fact that neural networks are in fact very susceptible to adversarial attack. And it really boils down to the fact that when you train a neural network to identify something like a banana, then it simply is looking at pixels. It has no concept of a banana. If you talk to a human being about a banana, they can define a banana in a million different ways. It's curved, it's yellow, it's a fruit, and so on and so forth. Whereas to the machine learning, it's just a set of pixels. And so the academics have been heavily engaged in finding fancy patterns of pixels, fancy patterns of things that you can put into images that totally confuse them. And Tesla discovered that when people put some almost invisible stripes on the road that would cause the car to change lanes, and so on and so forth. And so there were some Dutch researchers who had made T-shirts or little dots you could put on your forehead, which would totally confuse image recognition and facial recognition systems. So once again, if you are putting this into a system where there is a potential for adversaries, then you can get that. So looking at image recognition, you sort of say, well, if you've got a camera at the end of a production line that is looking for a defect where there isn't really a lot of probability of adversarial attack, that may be good. But if you're in other circumstances, that may not be quite so useful. And so you need, if you're going to do this, you need to include this in your risk management process, which is adopting one of these risk management processes, recognizing that the development process is different and it needs to be governed, having some kind of approval board that is understanding what the consequences might be of doing this, and also approving the way in which you are using the data. So I'm now going to finish off to give a moment or two for any questions by talking about some of the frameworks. Now, interestingly, I'm going to start off again with another piece of research that we have been doing, which is to do with these so-called AI service clouds and what we have seen around the world, the different strategies being adopted by different areas. And so the first thing is we've looked at the EU, the USA, and China. And if you look at the little bar charts, it's USA, EU, and China. So the first area is, does that geographical area have a cohesive strategy? Is it leveraging an innovation? Is it regulating or planning? And if you look, you see that China is somebody said to me that China was spending more money on AI development than they were on battleships. Whereas the USA is not, as a government or as a country, spending very much money. And in the middle of that, the EU has been spending quite a bit of time thinking about that. Then, if we look at regulation, once again, you can see that the USA has really not been paying very much attention to regulation. The EU has put an awful lot of effort into creating regulation. And indeed, I'm pretty sure that in the previous, in one of the lawyers that was invited to speak was going through some of that in some depth. And China is less interested in regulation. Now, when you look at investment in this, it's interesting because you can see that you can look at two kinds of investment. And this is the two slightly different purpley colors. That on the left, we have government investment, and on the right, we have private investment. So you see that the USA is putting enormous amounts of private investment and hardly any apparent government investment. The EU is investing heavily at the EU level and less at the private level. And China is putting all its money in from the government. And the final area is the degree of commercial freedom, where in a sense, the USA has almost unlimited commercial freedom. The EU is limiting the commercial freedom, as is fairly typical with the way the EU tends to do things. It likes regulation. And China is interested in regulation, providing it fits within their political model. And so this is an interesting perspective on how to look at regulation and where you're trying to compete and who you're probably going to have to compete with. And so the USA is going to be the Wild West, and you don't know what's going to come out of it, but what will come out of China will have been what China has decided is good for China. Now, when you look at the regulation frameworks, and again, there's another piece of research that we've been doing. My colleague Annie Bailey went through all of these different things, and you will see that the columns represent some of the areas that we have discussed or I have talked about throughout this, where we've put against the frameworks that we see that are being built up and which of the areas that these are covering. And so nearly every one of these frameworks is having a look at the ethical issues and technical robustness, but the agile involvement, data privacy and so forth tends to be less. Data privacy seems to be the lowest category after the one at the far right. And so for someone who is interested in this, you really need to think about where you're going to do business and which of these models is good to come out on. And when you look at it, the Singapore model is looking pretty good in terms of the comprehensive coverage within a free market economy. So to come to an end in this, what I think we can see is that AI is providing a rising need for ethical, security, and compliance resilience, that it is making us much, much more, and it is highly dependent upon data. and hence it becomes very vulnerable to any kind of tampering with the data. You know, if you wanted to thwart somebody's attempt to do machine learning, you would interfere with their data. And if that data is going to come from Internet of Things, then we all know how reliable and secure the Internet of Things is. So, or you can just create fake data, fake news. So that's the first problem that you really need to take account of. That we need to have a very clear dialogue with the people that are involved in and impacted by the use of AI wherever it is. Otherwise, we will find that regulators will stop us from doing it by creating impossible governance hurdles. And so there is an awful lot of good that can come from the machine learning and the AI technologies. What we have to do is to make sure that it doesn't go the way of genetic modification, where it is picked upon by the people that see it as a threat and manage to mobilize public opinion against it. This means that we need to have a very clear perspective and picture on the ethical perspective of this. And indeed, we're also going to find that we need to have security built in. And just to kind of put a final frightener on you, we also see an awful lot of evidence that machine learning is being used by our cyber adversaries to improve their attacks. When you look at the patterns of, for example, phishing emails, there is clearly machine learning taking place to look at which form of emails and which ways of delivering these is more or less effective. So with that, I think I've finished in time, and I should be able to say thank you very much.